Welcome to Math Minders Academy. So we want to look at conversion from one base to another. And we have carefully selected questions that will help us to adequately cover this aspect of the syllabus. Now, question number 1, we are asked to express 1, 1, 1, 1, 1, 1 base 2 to octal. That is, we are to express 1 in 1, 2, 3, 4, 5, 6 places. Base 2, we are to express this to octal. So how do we do that? Now, what it means, octal, let's take note that octal is the same thing as base 8. So we want to express that number to base 8. So what we do here, we have 1, 1, 1, 1, 1, 1, base 2. If we are to change to base 8 first, we need to convert it to base 10 using the expanded method. A video has been released about how to use this expanded method to convert to base 10. We will leave a link to that video in this video description, so you can go watch it if you still find it difficult to use that method to convert any base to base 10. So now we pick 1, that is this first number here, and we are left it 1, 2, 3, 4, 5. In fact, we can decide to do something here. The power of 2 here is going to be 0. The power of 2 here is going to be 1. This one, okay, maybe we do it. Let's see how we can make it a bit easy for us. So we have 1, 1, 1, 1, 1, 1, base 2. So we need to note that here, for these digits, the power of 2 is going to be 0. For these digits, the power of 2 is going to be 1. This is going to be 2. This is going to be 3, 4, 5. Okay. So with that, let's do our conversion now. We are converting to base 10. We take 1 times 2. So when we take this 1, this number here, times the base raised to the power of 5, plus we take the second 1, multiply by the base 2 raised to the power of 4, plus 1 times the base raised to the power of 3, plus 1 times the base raised to power 2, plus 1 times the base raised to power 1, plus 1 times the base raised to power 0. Now this is going to give us, if we look at 2 raised to power 5 is 32. And if you multiply 32 by 1, you get 32. 2 raised to power 4 is 16. 2 raised to power 3 is 8. 2 raised to power 2 is 4. 2 raised to power 1 is 2. And then 2 raised to power 0 is 1. So here we have 1 times 1. It gives us 1. So if we add up this and this gives us 48, this is 60, 63. This is 63. So when we convert 111, 111 base 2 to base 10, it gives us 63. But remember, our question requires that we convert to base 8. That's the convert to octal. So what we are going to do now is we are going to divide this 63. Here we are going to have our remainder. And then we are going to divide 63 by 8. If we divide 63 by 8, we have 7, that's 56. So the remainder is 7. Because 56 plus 7 is 63. We divide again by 8. But because 7 is smaller than 8, so that division will not go completely. So what do? We drop 0 here and bring the 7 down here. And then we move from down up. So that will now give us 63 base 10 now gives us 77 base 8. So therefore, what we are asked to convert, the number 111 base 2 is equivalent to 77 base 8. And that's the final result. Now, this is one method. We are going to use another method to show that there is a relationship between base 2 and base 8. That is what this number 3 is trying to identify, asking us to show the relationship between base 2, base 4, and base 8. So we can re-express this number now to alter without necessarily going through this method. Yes, there's a way we can avoid going through conversion to base 10 and returning from base 10 to base 8. I'm going to show that relationship between base 2, base 4, base 8, and all other multiples, all other numbers that result from raising 2 to any given power. So there's relationship. Let us look at that relationship now. Now, let's do something here. Let's draw this line here. Now, let's write down all the base 8 numbers that we know. These are the base 8 numbers. 0, 1, 2, 3, 4, 5, 6, 7. So if we are to list base 8, these are the numbers that we are going to get. Let's bring this thing down here. Good. So now we've seen the base 8 numbers. Now, we also know, we need to note that 8 is 2 raised to power 3. Now, if 8 is 2 raised to power 3, this 3 here is telling us something. I'm going to put 3 zeros here because of this power 3 here. I'll put 3 zeros. Now, I will divide these 8 numbers into 2. This is 1, 2, 3, 4, 5, 6, 7, 8. The first 4 numbers, that is 1, 2, 3, 4, I will drop 0 here. These first numbers, I will use 0 to represent it. Now, the last 4 digits, I will drop 1, 1, 1, 1 here. Now, coming here, half of this is 2. So this we have 2 zeros, 2 1s, 2 zeros, 2 1s. Okay. Now, for this last one, we are going to have 0, 1, 0, 1. That is 0, 1, 0, 1, 0, 1, 0, 1. Beautiful. Now, let's go back to this conversion here. I am giving 1, 1, 1, 1, 1, 1, base 2. I want to convert it to base 8. What will it be? I'm going to group this number in 3s. Look at the first 3, look at the second 3. The first 3 is 1, 1, 1. The second one is 1, 1, 1. Now, where do we have 1, 1, 1? 1, 1, 1. Which number represents 1, 1, 1? 7. So this is 7. This is 7. So it means that this number in base 2, when you turn it to base 8, it gives you 7, 7, base 8, just like we had before. This is very interesting. Now, let us look at what will this number be if I am asked to convert it to base 4. If you look at this number here, so now we've seen how to use this table here to convert 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1 base 2 to base 8. And it's actually very short compared to the method of expansion, which requires you converting to base 10. And then from base 10, you now move down to base 8. This goes straight. Now, the next thing we want to see is, can this table help us to convert this same value, this 1, 1, 1, 1, 1, 1 base 2 to base 4? Yes, the answer is yes, we can still use this table. Now, this is what we do if we want to achieve that. We know that for us to get 4, the relationship between base 2 and base 4 is this. 2 raised to power 2 is 4. So for the table that can be used to create a relationship between base 2 and base 4, that table will contain only 2 digits. You know, this table is built with 3 digits. Each line has 3, a combination of 1s and 0s, but there are 3 combinations. But for us to get that of 4, to create a relationship between base 2 and base 4, we need a table that we move only 2 digits. But we don't necessarily need to draw up another table. So we are going to use this. What we do is look at the digits that make up numbers in base 4. Look at this. If I'm to write down numbers in base 4, it's going to be 0, 1, 2, and 3. These are the base 4 numbers. We cannot get more than 3. These are the base 4 numbers, meaning that here, base 4 numbers will not exceed this line. Base 4 numbers will not exceed this line. So we are going to now do something. We can demarcate the table like this. From here to this place, move down. This is the table that we are going to use for base 4. So now let's go on. We want to convert 111 base 2 to base 4. So this is what we are going to do here. We'll come down here. We are going to group these numbers, these 6 numbers, we are going to group them into 2. Here we have this, we'll group it together, group together, and we group this together. Now we come to this table. Look at 1, 1. Which number? Remember this number here, they are all base 10 numbers. So which number here represents 1, 1? Of course, these base 10 numbers, when we bridge it from here and we have 0 to 3, they will form base 4 numbers. So 1, 1 from this table, 1, 1 is actually represented by 3. So we have 3 here. So the same thing here, the same thing here. So what it means, therefore, is that if we convert 1, 1, 1, 1, 1, 1 base 2 to a number in base 4, it will give us 3, 3, 3 base 4. Now the question is, how true is this answer? For us to understand that this result is true, we are going to convert this result, this 3, 3, 3 base 4, back to base 2, and we'll see if it's going to give us 1, 1, 1, 1, 1, 1 base 2. If we're able to achieve that, that is, once we're able to see that the left-hand side of this expression is equal to the right-hand side, then we'll conclude that this result here is valid. So let's move on to test that. Now, we want to convert 3, 3, 3 base 4 to binary, that is base 2, to binary, which is otherwise called base 2. Base 2. Now, first, we are going to, for us to convert from one base to another, we'll first move to base 10. So we're going to convert 3, 3, 3 base 4 to base 10. And it will give us 3 times 4 raised to power. If we drop 0 here as the power of 4, this is 1 and this is 2. So this is going to give us 3 times 4 raised to power 2 plus 3 times 4 raised to power 1 plus 3 times 4 raised to power 0. This becomes 3 times 16, that's 4 raised to power 2 is 16 plus 3 times 4 is 12. Take 12 here. This is 3 times 1, because we know this is 3 times 1. So we have 48 here. This is 12, and this gives us 3. So everything here is 63. That is base 10. Now, this 63 base 10 Remember, our idea is to convert to base 2. So we are going to convert this 63 base 10 to base 2. Drop remainder here. So we want to convert to base 2. We divide 63 by 2. It gives us, we divide 63 by 2. It gives us 31, remainder 1. Divide 31 by 2, we have 15, remainder 1. Divide 15 by 2, it gives us 7, remainder 1. Divide 7 by 2, it gives us 3, remainder 1. Divide 3 by 2, it gives us 1, remainder 1. Divide 1 by 2, because 1 is less than 2, we drop 0 here and bring the 1 down here. And then we follow the arrow from down up. So what do you see here? 1, 1, 1, 1, 1, 1 base 2. That means we have seen that 3, 3, 3 base 4 is equivalent to 1, 1, 1, 1, 1, 1 base 2. So that answer that we got before is valid. And so that is how we can create a relationship between binary and octal, that is base 2 and base 8, and between base 2 and base 4. So if you find this video impactful, please don't forget to subscribe to our channel. Click the notification bell so that whenever we release our video, you'll be among the first to get it. Then share this video. Go to the comment section and tell us how you feel about this video. Let's proceed to the next question. Question number 2, we are converting that number in base 5 to base 2. Let's proceed. So here now we want to convert 1, 4, 3, 1, 2 base 5 to base 2. We want to convert to base 2. So what we are going to do, we are going to use the expansion method. And so we remember the power of this is 0, this is 1, 2, 3, 4. So here we have 1, 4, 3, 1, 2 base 5 will give us 1 times 5 raised to power 4 plus 1 plus 4 times 5 raised to power 3 plus 3 times 5 raised to power 2 plus 1 times 5 raised to power 1 plus the last number here is 2. 2 times 5 raised to power 0. So this will result to 1 times 625. We have 4 times 125. We have 3 times 25. We have 1 times 5. And finally, we have 2 times 1. So that gives us 625 plus 500 plus 75 plus 5 plus 2. Everything will give us 1,207 base 10. All right. Now, this 1,207 base 10, we want to convert it to base 2. We want to convert it now to base 2, this number here. Let's see how we are going to convert it to base 2. So we have 1207. Want to convert, this will be our remainder. Now, we are going to be using 2 to divide. When we divide by 2, we'll get 603 here. Remainder 1. Divide by 2 again, we have 301. Remainder 1. Divide by 2 again, we get 150. Remainder 1. Divide by 2 again, we get 75. Remainder 0. Divide by 2 again, gives us 37. Remainder 1. Divide by 2 again, we get 18. Remainder 1. Divide by 2 again, we have 9. Remainder 0. Divide by 2 again, we have 4. Remainder 1. Divide by 2 again, we have 2. Remainder 0. Divide by 2, we have 1. Remainder 0. And you divide by 2 again, we have 0. We have 1 here. So it's quite long. Now we move from down up. We move from down up. This is going to give us, a value. This the value is going to give us. We have 100, so we write 100, 101, 101, 10111, 10111 base 2. So when we convert, we have 100, 1011, 0111 base 2. So that's what this conversion will give to us. So everything we have done this period is actually taking the same process. If you are converting from one base to another base, you convert first to base 10, and you use this long division, this repeated division, to bring it back to the required base. And of course, we have also seen the relationship between base 2, base 4, and base 8. Using a table to do such conversions is also acceptable. So this is how far we can go in today's tutorial. Thank you very much for your endurance. And we encourage you to go and watch the previous video that we have released that touch the other aspect of the syllabus. And then the link to those videos will be added to this video description. If you are new to our channel, subscribe, click the notification bell, share this video, like, and go to the comment section. Tell us how you feel about this video. Thank you very much for being with us. This is Math Minders Academy. See you in our next class, where we'll be touching another topic. Goodbye for now.
In the midnight glow where the stars align, we lose ourselves in the rhythm divine. Underneath the sky painted with dreams, we're chasing the echoes of silent screams. Caught in the spell of the cosmic night, where fantasies bloom.